Hello, everybody. Welcome, welcome, welcome. Take your time. Come on in. Grab a coffee, grab a drink, grab some water, wherever you are in the world. We're always international here. Morning on the East Coast, afternoon in the EU and in the UK on the West Coast. Some people are still waking up. I hope people are coming in shortly. But we're excited. This is going to be a really, really fun webinar presentation. I am so privileged to be joined today by Andrea Volpini of WordLift. He's the co-founder and CEO, and they have a fantastic product. And he's been kind of diving deep, not only into SEO ontology, which I'm not going to, blow up his spot on that. He's going to talk about that, but also just, the future of search, agentic AI. We are very much into this sort of transition from the traditional perspective of search engine and SEOs to more and more people using LLMs for search, using Google's AI overviews and now AI mode. This will be recorded, so a little bit of housekeeping is I am going to upload the recording and send it out via email when this is over, along with Andrea's deck. We'll also have a page where you can visit and review and watch. We are going to go through it. It's going to be very conversational. We're going to take some questions to answer, but I see people joining in the chat. Feel free to say hi. We'll take questions as we go through it. And so, Andrea, welcome, man. How are you doing?
I'm good. I'm excited. Thanks, Garrett, for giving me the opportunity. I'm in Rome, in Italy, so it's 3 p.m. today. I'm pretty happy to discuss a lot of topics with you, but also to take questions and try to learn more from this session.
All right. So before we really dive in, one last piece of housekeeping I want to call out is if you are in the New York area or want to come to the New York area in basically 1 month, iPullRank is hosting the first inaugural SEO week, which is a amazing conference, 4 days. Andrea's going to be there. Hopefully I will actually be presenting, but we're having 40 different sponsors or 40 different speakers from curated by our founder, Mike King. Each day is a different theme. So everything from the science of SEO, psychology, the ecosystem, and the future. It's going to be, you can get tickets either for the full week, for the 4 days, or just individual days. You just go to seoweek.org to check that out. We still have some tickets available, although it's probably going to sell out pretty quickly soon. So if you're in the area, please, would love to see you. We've got everyone from our founder, Mike King, Rand Fishkin, Lily Ray, Aleda Solis, and a bunch of different brilliant folks in the industry. So, hey, Sylvia. Hey, Ray. Welcome, everybody, for coming in. Yo, Ray. Yo, Sylvia. Okay. I'm seeing like some familiar faces. It's always exciting.
It's our community. It's our community. That's good.
Yeah. Ray's team is sponsoring, so man, it's going to be a fun event, and I get to hopefully meet you for the first time in person, Andrea. But
yes,
without further ado, let's get this going and take it away.
Yeah. So we're gonna discuss about AI optimization and more of a conceptual framework. I'm Andrea. I'm been working on SEO and now it interacts with natural language processing, semantic web technologies, and I want to start with with something that kind of shapes the way in which we're doing things, which is the so-called poker paradox that sheds some light on how things are evolving in the world of large language models. And so I have a question, which is quite basic. Who do you think won between a computer that has been trained with 1 trillion ends and at 10 milliseconds to take a decision versus, a few very brilliant human poker players that had a handful of 10 million ends played, but had the luxury of taking, 20 seconds for thinking. What do you think, Garrett? What is your take?
It's a fascinating question. No, it's so good. And I'd love for people to answer in the chat as well, because it's like, I know, over the last, 10, 20 years, we've seen, machine learning models of AI, like trying to beat grandmasters in chess, right? That's like one type of complex. We've
And
seen
then
Go, which is like an
Go.
even more complex game. But when you're starting to talk poker, like we're talking about so many different contextual stimuli, you know, so much different context. And so like trying to think fast versus like think slow.
Right. What do you think? I mean, there is also a huge difference in the numbers here, because I mean, 1 trillion hands versus 10 million hands, right? So there are two dimensions. You know, one is how many samples you have seen as either human or machine, and the second dimension is how much time do you have to provide a response. Yeah, probability is in favor of machine. It's 2025. Come on, I mean, you know, we should be able to assess that the machine wins, but as you can imagine, no. The human expert won.
We're still like
there is still a chance for us to, you know, to win poker.
Yeah.
But listen, this only works if we're, you know, keeping the machine acting within system one. So fast thinking. Just a quick intro. System one, system two. It's oversimplification of how the brain works and how basically we can combine intuition, which is, you know, system one, the natural way in which we can ride a bicycle. Okay, so we don't think too much about what we have to do when riding a bicycle. That's happening fast. And intuition based system one, and then system two, it's like everything that, for example, we would do to learn how to ride a bicycle. I don't know if you remember, but I had kids, so I've been gone through not so far ago, and it takes time, right? Because system two needs training. We have to understand, okay, how does it work? Like if I move the pedals forward, then maybe there is a balance, and if there is a balance, then I can progress, and then I can ride the bicycle, and then, you know, system two brings, you know, notion to system one, and then we can get faster and do it naturally. So these are kind of two worlds of way of thinking, and they apply to the way in which humans reason, but they are also extremely important for the way in which we build machines. And as you can imagine, you know, traditional neural networks, it's a pattern matching machine, as we know, especially if we look at these large language models. So they are capable of you know, predicting the next token. You know, the cat is on blank table, or the cat is on blank mat. So the system will very, very quickly predict, you know, the next token, and it's doing this by analyzing the patterns in its training data. Now, on the other side, and that's more, you know, the side where I come from, which is, you know, we would call it symbolic AI. And it's like you have an expert system that has, you know, the notion, for example, of a bicycle, and the notion of balance. And then you have some rules that help you understand, you know, okay, how can I keep the balance by moving the pedals? And so the difference is also in time, because, you know, to learn to ride a bicycle, it takes a lot longer than to actually execute, you know, the skill. But the reality is that the ability of this model to learn through pattern matching, it's been exhausted. Why? Because we have one internet. Sorry, but we only have one internet, and it's been exploited. You know, and of course, it's highly debated, right? We all take a great care of our content. We're not so sure it's legit that an AI company would use our content. It's fair use, not fair use. We still don't know. But what we know is that everything that a machine could learn with just one internet, it's been, you know, done. And so this is
so interesting to think about, to me, just in terms of like the sense of the scale, because we think about like we as humans, we struggle, I feel like, to think about scale. Like when you're saying the internet, you're saying like every single document that's been published on the internet that's accessible across all time, whereas you're saying like that's not enough data. Like it's like the LLMs of what is the limit of what they're capable of. When we think of like the trillions of neurons in the human brain, like it, despite the entire internet, it's not comparable to what our brains are capable of. So it's like it's interesting to think about that sort of limitation we hit already.
Oh yeah, of course. But so the reality is that this is the connectivist theory. So the theory that we can build something very similar to the human brain by using a neural networks and by training this neural network with a bunch of text. Okay. And this is what brought us, to the first GPT model. We know that the T, it's something that it's foundational, invented by Google. It's the transformer architecture. We are still highly dependent on the transformer architecture. But this guy here that knows a lot more than all of us combined about AI, Ila Satska, he told us, very recently, it's done, right? Pre-training, which is the phase in which we build the model by feeding, training data in order for it to learn the patterns, has reached, its peak. Now, the reality is that by working on this poker paradox, the team at OpenAI at the end of 2024 demonstrated that it is equivalent to dedicate more time in thinking than to feed the model with additional data. So as you can see, the system 1 and the system 2 are converging. So I can either provide the models with 100,000 samples of training data, or let it think, take the time to think. Just recently, you might have seen, but one of the interesting experiments that the team at Anthropic has done is to create a new tool for agents that it is just providing the agent with the ability to think through. So it's a tool that is designed to take the time, right, to move, the process from system 1 to system 2. And apparently, it's proving to be successful. And so it is in this poker paradox. And I've been, playing with this. When DeepSeek R1 came out first, it was a shockwave for the AI industry, because they've been able to reproduce with a limited amount of resources, with constrained GPUs, successful model that was actually trained using reinforcement learning. And so I started to tinker, like I do, like in order to understand, I do things. And so I reproduced right after the paper was published. I reproduced the so-called aha moment. So what is happening here is that I trained the model to do exactly what the team at DeepSeek has done. So I trained the model to think how to answer to these algebraical questions. And so what you do here is that the training data set, it's no longer about, the cat is on blank, and it's not about the instruction type of training, which would be, what is the capital of Italy? The capital of Italy is Rome, right? So you have like a question, and then you have an answer, and that's the instruct model. Here, you're actually training the model to think in order to provide to the correct answer, and the correct answer is highlighted by the reinforcement learning process that takes place during the post-training. You actually help the model to do the right thinking steps. Now, this is beautiful, because as you do this, you can train the model not just to fill the blank, you can train the model not just to provide you an answer, but you can train the model to think like you do. Boom.
Wait, so you're saying, like, basically you're providing the logic for the model, and then once it has those logical steps, like, then it can do its own reasoning?
Yeah, that's correct. So we're feeding the trails of the reasoning behind a successful answer. We're also feeding the model with the trails of reasoning without an unsuccessful answer. And we're just saying, yes, this is good. No, this is bad. And so the machine doesn't just learn the correct answer, but it learns how to achieve the correct answer. And by doing so, on a diverse, number of subjects, the system learns how to think, right?
And I think with OpenAI, it's like they kept so much behind the black box. To your point about DeepSeek, what was so interesting, I think, for a lot of us who aren't like in the weeds of building these models ourselves, is seeing the transparent reasoning and seeing how DeepSeek was getting from the query, the conversational search, to the answer, was like, I felt like a aha moment for your normal non-developer.
Yeah, we have learned so much because of open sourcing, right? And and the Poker Paradox, it's a research done by OpenAI, but it was until the paper from DeepSeek was released that we were actually able at scale to reproduce some of the genius decision that they've taken, including the way in which attention is calculated into these models. So long story short, we started with base models, so predicting the words, and we venture now into reinforcement training. So we learn through practice. It's just like going to school, if you think about it. Like it's we go to school, we learn how to make algebraical operation, and then there is a teacher that corrects the exercise, and then we do more and more exercise until we become familiar. And guess what? I mean, we're moving from system 2 to system 1 through the exercise, through the practice. So we have learned that we can actually use the same approach in order to make the model reason. And now we are entering into this area where search is added. So the model is not only able to reason, but it can also trigger a tool that will run search across the web, and therefore would be able to reason and search additional information. And so the form of intelligence that we have today, it's a combination of learning and search. That's what we have today, right? This is the kind of the solution that we have now. Generally speaking, a lot of the AI, it really comes down to knowledge representation. So if we want to oversimplify, what is the quest for AI? Right? The quest for AI is the quest for representing knowledge. And that's pretty much relevant for human beings as well as for intelligent machine. And we can represent reality, in discrete pieces of information, like triples in a knowledge graph, like Garrett works for Apple Rank, or Andrea lives in Rome. So these are factual based information that can be represented in subject, object, and predicate. However, we have learned, because of the advance in natural language processing, that we can also transform a concept into embeddings. So a mathematical representation in a low-dimensional space that allow us to understand, for example, then male and female are within the same area, or maybe cat and dog are in a different area. So if I bring semantics and I kind of apply math in order to bring all these concepts on a single dimension, then I can see how distant they are. And so every concept can be equally represented by either triples, discrete pieces of information, or a continuum, like 0 and 1. How distant is Andrea from male? How distant is Andrea from a cat? Hopefully, I'm closer to a man than a cat.
It's so interesting to me too, because I think when we're talking about AI, a lot of people can like almost anthropomorphize, like give sort of personification to the machines, and we have to remember ultimately it's still machines. To your point about the vectorization, is we're taking these concepts, we're taking these words. The machine is never like seeing anything, it's never understanding anything. It's really just taking these mathematical values, identifying their relationships, and then like kind of almost mimicking this understanding based on the significant amount of data and the way that they're mapped, like in this 3D dimensional space.
Right. So the advantage, though, is that in order for us to provide the machine with additional understanding, we can actually combine these two knowledge representation. Today, in our knowledge graph, when we have to describe Garrett, we have an entity for Garrett. We actually have a knowledge graph for Apple Rank, and we have an entity for Garrett. And Garrett entity has discrete attributes. So, for example, the affiliation with Apple Rank, the fact that he knows me, and a bunch of other people. But then we also have converted the bio of Garrett into embeddings. And why we do that is because we want to let the machine see Garrett from either the continuum representation of the neural model, as well as the symbolic dimension of Garrett. And so these kind of two dimensions are helping us understand and let the machine understand the reality that we're operating with. And so there is an interplay between the two, and in a way, this is helping us address the biggest problem or the biggest opportunity if we come to, AI marketing optimization. The consideration that today's large language model have no memory. When you stop chatting with ChatGPT, the model itself, it's not going to be retrained. He has the same understanding of the world that he had before he started chatting with you. And that's very different from us, right? After this conversation with Garrett, I will know more about, certain topics. And I will rewire, there is a phenomenon called neuroplasticity in our brain that would allow us to rewire part of the brain as we learn more. But that doesn't happen in today's architecture. And this is a beautiful way of Claude 3.5 of expressing this, isolation of a language model that realized that, it doesn't have any memory and therefore it cannot create, everlasting relationship like the one that we as human build. And it is, kind of intellectual isolation of this language model that we want to address today. And of course, it's also a way in which we as marketers can start to think, okay, how do we, do our work with these systems? And so I, a while back, I started to think, okay, if, it's becoming so strategic to build memories for AI system, and this is going to be the next generation of marketing techniques, how do, memories create and are built inside the human brain? And so I found this Jeff Hawkins theory called the 1,000 brains theory, that it's a fantastic framework for understanding how we build memory into our neocortex. So imagine that we have 150,000 spaghetti into the neocortex. The neocortex is the new brain, also called, right? So it's what differentiate sapiens from primates. It's the new part of the brain, and we have all this spaghetti here, and each one of these cortical column has a representation of the world, and the representation is built by predicting what's going to happen. So, for example, if I touch this WordLift pin, as I move the finger, the cortical columns will predict, what is the sensation that I'm going to feel as I keep moving the finger, and so we build, reference frames. We build an understanding of the reality by bringing together, these different representations from the different cortical columns. So there is a voting system inside our brain. We are not always so sure that, this is a microphone and I'm in Rome and this is a table. We build this understanding through a voting system. And of course, every cortical column is bringing on its own understanding of the world, whether it's a visual, it's tactile, it's auditory, it's olfactory. All of these sensations together are kind of building the representation of reality. This is why AI, in the end, it's a knowledge representation problem.
Right. So, and to speak to that too, what's really interesting, you think about individual people, is the reliability of memory, because we only have our own subjective reality. So we have like a social contract, what everyone agrees to be real, but what you can see, what you can hear, what you can touch is going to be your own personal experience. So if you are taught something wrong, and that's your model, that's going to be influence how you think about other things. I can just see where you're going with the AI.
Yeah, absolutely. I mean, so we have our own biases, and our own biases are trained within the system over the years, and of course, it's a distributed process. So memory, it's not a static process; it's a distributed process. And we have, these different cortical columns that are separately creating a different representation of the world. And so I started to translate this into SEO. So I started, okay, so now that I understand how the brain works, and now that I understand that language model are not sufficient in order for us to advance in building this intelligent machine, because they are finite, and they cannot learn, they cannot adapt to reality, they cannot create, everlasting bonding relationship with external world. I started to design, with our team, what we call Ontology, as a way of representing SEO data and marketing data. Because in order for us to create agents that are able to do the things as we want them to do, we have to build a memory layer first. Because, language models are becoming a commodity. Let's be honest. Today there is a language model, tomorrow there's going to be another one, right? And even during the course of the same day, we saw yesterday, OpenAI was showcasing the ability to create fantastic images, and it's not DALL-E 3, it's way better than that. But then on the same day, Gemini 2.5 came out, and it's the best language model in the world. And so every day these things are evolving, and so we should focus instead on building memory. So in the end, SEO Ontology, it's a reference frame, and it's interesting because I've been doing this talk now for a few months, not so much. I haven't done it enough probably, but there are people that are coming to me now. Okay, there are people that are writing me on LinkedIn and they're saying, "Hey, I'm totally inspired by this thing, and I want to contribute, and I want to, kind of share my vocabulary for SEO." Because the first problem that we have when we represent knowledge is that, if I ask, Garrett, what is EAT, and then I ask, maybe Ray, what is EAT, I'm not sure if they are talking the same language. So the first objective is kind of having a common language for SEO.
Love it.
How about that, Garrett? Do you like the idea?
And well, it's so important too, like, because now we're starting to get into, as more and more people, are getting traffic from these LLMs, and more people are using them. It's like you need a practical solution. And so that's where you're kind of future thinking of, like, as it's more and more fragmented, whether it's, to your point, a commercial solution, or even eventually an individualized, like where we all have our own LLMs, there still need a source of truth. And that's this.
And a way of representing the data. For example, I give you another example. Like, okay, you have these, the page of this webinar, and then you have the form, and then what is the search intent behind the people that are reaching to this form? It's a transactional intent. It's the intent of someone that wants to learn more. So defining the intent behind the web page, it's a way of representing information for the web page that any agent can act on. And so I started to think about like a map. Okay, what if SEO is a map? What if we want to feed agent with the Cartesian map of the clicks, the queries, the search intents, the source, the structured data markup, the traffic coming from large language model. All of these concepts that in the industry are becoming kind of a shared knowledge. I want to formalize them so that they become a shared knowledge also for AI agents. Mm-hmm. And that's why we decided to put this effort as open source. This is critical for our product, but it's also an open source initiative. Why? Because I want, demand sphere, since Ray's here, to also leverage, when they crawl a web page, I want to share, the same concept with them. I want to feed my system with their data. I want to share my data with their data. Today, we were having a discussion on X about embeddings. Like you calculate the embeddings, for example, for a web page, and then maybe I have to do an optimization on the same web page. Should I recalculate the embeddings, or can we save the environment and I can reuse the embeddings that you have already calculated? Because a lot of these processes are also redundant. We know how many crawls are needed. We do this crawling all the time from scratch as if there is no tomorrow. But actually, we could share it. We could say, okay, that's the crawl. That's the crawl from last week. Good enough? Yes. Okay, let's use it. So we started to do this in order to bridge the gap between structured data, because of course you might argue that we already have a vocabulary called schema.org that search engine are already using for standardizing some concept like, okay, this is a product page, or this is the about page, or this is a person that works in this organization. So I don't want to overlap with schema. I want to stand schema, right? And I want to add, whatever is missing in schema in order to facilitate the creation of these AI-driven workflows.
Which is so interesting too, just to your point about everything like the crawls, it's all being resource intensive. And, everyone is thinking in the grand scheme of things is like, how can we save money? How can we save resources? And while AI can do a lot of the understanding of what's on your page, using things like structured data makes it so much easier for it to ingest all that content. Like the whole point of this is the organization of information, because people will say, well, why do I have to do it if the bots can read all my stuff anyway? Well, you're more likely to be included in the output if you're making it as easy as possible for these LLMs and the crawlers in the first place.
Yeah, I mean, the point I think, and this is a complete new and ultra interesting debate, whether we need in 2025 structured data or not.
Right.
Here I'm talking about an extension of structured data, but just shortly on structured data, the idea is that you want to express your viewpoint with the data, right? You wanna say that you have labeled that page as a product page, right? And there is a value in you saying that to AI system. At the same time, you want to save, effort. You wanna corroborate facts. You wanna, reinforce, relationship between entities using, structured data. So one of the things that we're doing with SEO Ontology, one of the use cases that we've been focusing on is of course building internal links, because when we work on large scale websites, we have autonomous system that creates these internal links, but they have to be fed with dynamic information coming from Google Search Console. And so one day, page A, it's getting traffic from, query X, and then the next day, everything changes. And this is a memory layer. Like, I don't want the model to be exposed. I want the model to get that memory into the context, or, to be trained with that memory in order to design the best anchor text, in order to create the best link at that point in time. So memory, it's really effective. And we will see these, of course, extremely relevant also for interacting with the Gemini or the Perplexity. Why? Because, of course, these systems will rely on memory, and memory will be a key differentiator. We already see on Gemini that they're talking about, heavy features that will be dependent on personalization and, different ways in which the AI can be influenced. So we basically have, we have this map that allows any agent that we build for automating marketing tasks, that makes the agent aware of the notion of, for example, what is an organic click? What is the relationship between a query and the way in which I should write the link? And so by adapting, by feeding the data into the system, into the memory layer, then the system adapts dynamically. So it becomes smarter, because then it can learn that, for example, with that link, performance went down or up. And so it can change the behavior. And then, of course, we have, kind of re-ranking process here. And it can be very complicated because, of course, in large enterprises, you can imagine that it's not just about preventing cannibalization. It's also about understanding, the business priority at that point in time, and or maybe the user needs. So the re-ranking is where we actually kind of, fine-tune the memory layer in order to say, hey, kind of, boost these today because, it's Black Friday's coming or something like that. So back to the concept of SEO Ontology, we want in the end the domain expert to be in control. End of the day, symbolic AI, it's reassuring. Symbolic AI brings the human at the center. Why? Because, we still need the expertise of the SEOs to model the memory and to provide, the key data point to the agents in order for reaching, the business goal. So we can have a user, like a business user, that say, okay, optimize this web page. And then you have the SEO that, okay, in order to optimize to the web page, I need, I don't know, these and these data point. And that's the memory, that's the capital that I want to give to the agent. And then I want to infer, for example, that the agent will have to use these rules. And so then you have the AI agent that does the work. And so again, it's a balance between, how much we want control and how much we want an AI agency. And right now, people are not thinking in these terms. I know that a lot of people are just, throwing stuff at ChatGPT or Gemini or whatever. And then, they expect that something comes out and there's no control. Maybe it's okay for links, but, there are a lot of other things that where you need control.
Yeah. Yeah. I mean, we're not at the point where AI, and maybe we do eventually get there where, machine learning is so advanced that it can do this without like the human in the loop, but it's so far away from where we are right now, I feel like. And especially, to your point where it's a large enterprise and there's so much at stake, you need the safety guardrails of the, person in control, to make sure that you're not making really dramatic changes that can impact revenue, that can impact, visibility so dramatically.
One of the other elements of these memory layers that we're building for enterprises, for example, has to do with the tone of voice. Because the content is becoming dynamic and it's generated maybe on the fly by an AI agent on behalf of the marketing team, there's one thing that remains. It's the tone of voice, because you don't want, to lose the brand legacy. You don't want to lose, your characterization in the dialogue with your users. And so how do you kind of feed and enforce these tone of voice, these brand values? It's really by building memories. And this applies for your AI, but it also applies for the AI that you're trying to influence, the third-party AIs, the Perplexity, the GPT search. The same approach applies there.
So cool.
So here, there's some kind of some code that you can try and that will give you a sense of how this works. So you have an agent that would get from the say ontology some of the key understanding of how links should be built, and then with chain of thoughts would take the time to generate the anchor. And so this gives you an idea. So you have an agent that does create the anchor, but then you have an SEO that has created, the relationship that should be used by the agent to create the anchor, or can be used by another agent to validate if the anchor created by the first agent is valid or not.
So cool.
And of course, this is kind of a flow diagram of how these interaction works. But you can see that the large language model, and here I'm using a framework called the SPI that it's actually quite interesting because it removes the need of prompting, and it's more like machine learning oriented. So you have a training data set of what you expect to achieve. And then you have an evaluation criteria that helps the model understand, how to evaluate the output. And then the system will automatically adapt the prompting. So you don't do the prompting with the SPI. The SPI will automatically adapt the prompting based on the outcome and your evaluation function. So I'm using this. And then on the memory front, I have the SEO ontology. So I have the concepts that as an SEO, I want to transfer to the process in order to retain some control. So
that's so interesting. It's like working backwards, basically. The result you want to get, and you said it's to basically automate and do it all itself. So it's the results are managed.
Yeah, results are managed, but you're feeding the system with the key data points that are needed in order for that process to succeed. And so we're kind of maintaining these on GitHub, and yes, I mean there is some work that we're doing. Very small community at the moment, but I hope it will grow, and definitely it's becoming substantial for us building the knowledge graph and automating a lot of the tasks. But it's also given me then an insight on how we can influence a large language model. How, as a marketer, can I do SEO, right? We cannot talk about ranking, right? We cannot talk about, how to rank on ChatGPT. I mean, there's no way of ranking. I mean, it's a stochastic system. Every time it's going to be different. So I need to establish a framework. I know that I can work with high-level concepts like entities, but I have to understand what does, influence the system. And so one way to understand the influence on a system like Perplexity or ChatGPT, it's to think in terms of memory. So semantic, episodic, and procedural are three different types of memory. So semantic, it's for example, entity-based. Everything that Gemini knows about, a pair of shoes or a pair of sunglasses, it's described into Google Shopping Graph. So there is this giant memory of things that represent billions of products into Google Brain. And this is a semantic type of memory. So it's factual, it's fact-based. How do I integrate with this semantic memory? I mean, if I'm working with Gemini, Google AI Overview, Google AI Mode, you name it, there are ways in which I can influence the semantic memory. For example, I can use structured data, or I can use the Google Merchant Feed in order to update information about my products, update information about the way in which the product can be shipped. And so I'm acting on the semantic memory layer. Now, episodic memory is how, things have happened. For example, in the context of marketing task, what workflow was successful with this type of website. So when that happened, so it's the when. In the case of for example, Bing Copilot, if I feed Bing with event metadata, like, okay, SEO week is coming, that's an episodic type of memory. Everything that's going to happen in New York, it's going to be stored, as an episodic type of memory. It's going to be linked to a specific point in time and a specific location. And then we have procedural memory. In schema, we would represent these with the how-tos. How do we prepare pasta? How do we organize a conference? I don't know. I mean, these are things that Gareth has learned now along the way.
Top of mind right now.
So these are categories, and we can think, okay, my client needs to have, better positioning on ChatGPT, but we need to work on the episodic memory of ChatGPT, or we need to work on the semantic memory of ChatGPT. So you can start thinking in terms of, marketing tactics in order to influence these three types of memories. And of course, there are different systems behind each of these types. For example, I was in a conference in Milan like a few weeks ago, and I did an experiment on Grok. I kind of love Grok. I hate X. I love Grok. And it happens, right? I'm
curious. Yeah, I hopefully you'll expand. But what do you love about Grok?
So Grok is very deep and it's extremely fast, and the quality of the response for a lot of the scientific questions that I have, it's very high value, and it's way better than GPT 4.5, for example, for a lot of the areas that I test this model on. I also like the fact that Grok, of course, speaks like with no filters, or kind of no filters. So you can say you are an evil bastard, and it will say yes, you are also an evil bastard. You will never get this level of confidence with, for example, an OpenAI model, or even worse with Google, right?
Right.
So less filters, very deep in reasoning, very well on scientific responses. So that's what I like of Grok the most. Anyway,
and that's just something top of mind, I think, for marketers, and like how you're trying to market for different specific types of models that people use them more, is understanding what the parameters are that filter, the constraints, that are put. We know there are a lot with DeepSeek in relation politically, there's a lot with Grok politically, and then obviously Google, there's so much fear of saying anything wrong and trying to be as kind of balanced as possible. So it is a layer of the marketing aspect of this, which
it is. So and then the other layer is like, okay, where is memory coming from? And so I was at this event, and then I asked everyone I was the talk. And I said, okay, write on X, write on Facebook, and then we had a poll on X, and then just immediate right after, we asked about the talks at these AI festival, and imagine there were like up to 200 talks during that day, and Grok highlighted my talk. And he said it was mesmerizing. And the reason he did that is simply because we were able to feed instantly the memory by just, creating engagement on X.
Interesting. That makes sense.
So memory is very volatile, right? You can influence memory right away with the use of social media. This would work very well with GPT search as well for specific queries. So if you create, solid engagement on social, then you will see that this engagement reflects on the understanding of the world that these systems have, because they heavily rely on social for, their memory layer. And of course, quite obviously, Grok, the relationship with X is very strong. And so everything that is being said on X, acted as a primary source. And so if you can influence the debate, you will get definitely an edge on shaping, Grok understanding of the world.
It makes so much sense. And also, just the other thing that I'm obsessed with, which I think about, is depending on the platform that you're using, search behavior is going to change. I feel like someone is going to interact with Grok and ask a certain type of question that's going to be completely different than what they put into Google versus ChatGPT. So it's like that's a whole other layer of like the human, aspect of, you're going to see different types of searches on different types of platform, knowing their capabilities and, the proclivities that they lean towards,
Yeah. So these are aspects that in the end we need to master, in order to interact with these systems. And then the other aspect, of course, is that we have to come to terms that at least, this is a very conservative estimate, at least 1 trillion in e-commerce revenue are going to be generated by AI agents acting on behalf of humans. So your next client is not going to be, in flesh and blood. It might be, just a robot. And that is a tremendous transition, because that kills, everything that we know about user experience, for example. And I have created, let me see if I can share these. I've created, this is, I don't know, really a wild demo, but hello, hi.
Hi, this is Sarah. How can I help with your shopping today?
You don't hear it, but it's speaking.
We can hear it. We can hear it. Or I can. Yeah.
Cool. Okay. I'm looking for a pair of shoes.
Great. To help me narrow down the options, could you tell me what kind of...
So this is an experiment that I'm running, and it's called Shopping AI Research Assistant. This is designed in order for us to understand more about these systems, but it's also designed for building a shopping search engine using audio agents. And so this is a very practical example, right? We're gonna make the next purchase just by talking. I mean, voice search SEO is back finally. I mean, I've been predicting voice search for years, and I was always wrong. Now, finally, maybe this is the year that it's happening.
Well, the interesting thing of what you were showing too, and I know I've seen Christian Word of Yext talk about this, is the idea of the reverse prompt, where it's like, the first 2 years since ChatGPT went mainstream is like we're trying to figure out how to write the best prompt for, these models. Whereas in this experience, the AI model is basically asking us for more context to provide the better answer. So that's going to be another element as well. Is like a lot of, when you think about this for practical purposes, what the average person, how they feel comfortable interacting with, an agent in the first place. If the agent is asking them the questions, you're going to get a very different search journey than if they were unprompted and just doing it all themselves unaided.
Yeah, this is also has to do, of course, with the ability of the agent to reason. This is why, in the beginning, I wanted to introduce this idea of, how do we train a reasoning agent? Because, of course, in order for me to make Sarah successful, I need to train it to ask the right question about the products that I know are needed in order to help the consumer find what he or she is looking for. And so the ability to train on reasoning and not to train on providing the right answer, it's becoming, extremely, extremely relevant. And so generally speaking, marketing, and everything that we're doing, it's about memory creation. And it's not just about, it's no longer about optimizing for the search intent. We started with keywords, and then we move into entities, and then we started to understand that entities kind of shed lights on search intent. But now we have to think in terms of memory. What is influencing the memory layer of Sarah or any AI shopping assistant out there? How do I act? It's a semantic memory issue, or it's an episodic memory issue. For example, reviews are episodic. Like, I can influence, the understanding of the qualities of a product just by, for example, reinforcing positive review around certain product. And that would create, an episodic memory into these AI agents that would, kind of make them lean towards one product or the others. For sure, it's not going to be the user experience of a user on a website. I'm no longer going to see the site other than, for my personal interest or exploration or in-depth dives. But if I need to buy a pack of batteries, or if I need to buy a shampoo, I'm possibly not gonna see the website behind it. I'm just gonna, find the right product, the best product for me. This is fantastic from the consumer perspective because it gives us access to, an infinite number of potential variation and things that I like. And we have someone that is doing the heavy lifting that maybe we didn't want to do for a shampoo. But now there's, an AI that
so interesting, man, because it makes me think about like if you're not seeing the website, the opportunity of the marketer to persuade is reduced significantly, and it's really become so much more about being one of the options that the AI agent provides. Like it's less about getting them in there and being like, use your system one thinking, your emotion to choose me, and more about like, well, the system two is working, it's reasoning, it's getting the options for you, and then you're just selecting from those three options without maybe any of the additional context outside of what you just have directed the AI agent to do in the first place.
That's correct.
Wow.
So yes, and then of course there are kind of technical ways in which we can facilitate the interaction between an AI system and our product catalog or corporate website, and of course LLMs.txt. It's one of these ways. It's a form of a robot TXT for AI system that solve a few problems. So the first problem is that, of course, that HTML is complicated, and as we know, a lot of the AI system would not have the luxury that Google has of rendering JavaScript or even understanding complex HTML. So this is a markdown representation of the content that you have on the website that it's kind of designed to fit into the context window of a language model. So it's kind of a custom representation again of the pages that you have on your website that works well for an AI system that doesn't have the ability to render JavaScript, that doesn't need to have the ability to understand HTML, or even if he understands very well HTML, you don't want to feed the context with HTML tags. You want to actually feed it with your content. And so LLMs.txt, it's becoming kind of a solution for part of this problem. Another big solution that you will hear a lot is the Model Context Protocol. This is an initiative by Anthropic that it's designed for making APIs available and accessible to language models. And so we are also, we're generating now this LLMs.txt out of the knowledge graph. We're also making the knowledge graph accessible through MCP because, the next catalog, the next e-commerce website is not going to be built with pages. I mean, yes, there would be pages for users that still want to use the browser, but, we have to work for the agentic client. And so the other aspect that I want to talk about in terms of how do we influence a large language model, it's really the understanding of sparse out encoder. So these are networks, these are transformer based network, super simplified, that work with an encoder and a decoder, that are trained on the activation neurons of a language model. Okay, so you have a language model that needs to be open source because you need to have access to the activation neurons. So you need to know what neurons will activate when I will say hyperrank. Okay, if I say hyperrank, I want to know the activation neurons of the language model, and then I want to train on top of that a sparse out encoder. By doing this training, I can create a representation of the concept that are activating. And I can filter, the concept that are monosemantic. So these are concepts that, much similarly to entity, have kind of a stronger power into the network. Let's put it very simple. So these are concepts like, I don't know, Golden Gate or SEO that have so much power that are represented within a single neuron. And I can detect this by building this sparse out encoder on top of the language model. Because when I say, for example, SEO, when I say I pull rank, this sparse out encoder will try to make the network converge between, the words that it's expected to be predicted and the neurons that have been activated. And so I can, by doing this, I can see, for example, that Golden Gate, SEO, and hopefully I pull rank have, a strong presence into the model, so that within that neuron, there is only one concept. Because typically, because we have more concept than neurons in a neural networks, you might end up in having a neuron in a large language model that represent a Python script, and then, I don't know, tape, and then a word in Korean. And it's all together. So it's called superposition. So you have one neuron that have, different meanings that activates depending on, what sentence are getting in and out. By understanding this monosemantic feature of the language model, we can understand, like scanning the brain of a language model, and understand what does it understand about a specific sentence. And so we have now the ability to run this sparse out encoder. And so here in this experiment, I'm detecting what are the neurons, what are the features that activate on Gemma when it reads WordLift. And guess what? It activates on features like SEO and RDF. RDF is the standard of knowledge graph that WordLift uses. In SEO, of course, we all know what SEO is. And so this gives you kind of a proof of the pudding that you have been able to influence that pre-training phase. That the language model, in this case, Gemma, it's understanding WordLift, and it's connecting, within its brain, WordLift to SEO. And then,
that's so cool. So it's basically like understanding the strength of your entity with the attributes that you want it to be associated with in the context of the specific model. So to your point, it's like that ability to measure how good you're doing at your marketing and, your
right.
kind of context building. Yeah.
I mean, of course, this is the ability of evaluating how good you have been, because of course, a lot of these models have been trained, maybe 6 months ago, maybe a year ago, maybe 2 years ago. For example, we can see these on GPT-2, and then we can evaluate, how it is different from, a latest version of Gemma, or we can use, the DeepSeek models. And then we can see that, for example, a concept like WordLift might have changed, in the representation that exists within this network. But we understand this by extracting these monosemantic features. So these monosemantic features are indeed the equivalent of entities inside large language models. And these monosemantic features are also helpful, for example, for directing, the model. So we can use them instead of retraining the system to say, okay, write these like a pirate. And pirate, it's a monosemantic feature. And so it would emulate a pirate talk simply because I'm, kind of tuning up the monosemantic feature of pirates. Or I can tune down, the monosemantic feature of Elon Musk, for example. And then it would be, more
for your content. Yeah, it continues to be as relevant as you specifically want it to be going forward.
Yeah. Wow. That's all.
Dude, okay, so many thoughts. I almost feel bad because it's like we have these sort of, you put together this presentation and there's so many questions and it's hard to like keep it all contained. But this was so interesting to me because I feel like you are kind of looking through the crystal ball despite nobody knowing definitively what direction all of this is going. It makes so much sense the way that you and your team have been building out these, the knowledge graph, the technology, the future of market. Unfortunately, it feels less sexy to me as a marketer because I'm like, oh, I don't have as much control to persuade, through like, the web pages. Like I can see now when Google predicts a future without websites.
It's quite obvious. It's quite obvious. But that doesn't, you shouldn't feel that way. I think that you should feel because end of the day, okay, you have to work on memory and you have some limited control on the language model itself, simply because it's trained on a specific schedule, and in most cases it's kind of obscure the data sources that are used. Of course, being present on, Wikidata, being present on,
the C4 in the first place.
C4, we know that this has an impact. Of course, I mean, I have a lot of friends now that are publishing data just for the sake of being visible on Hugging Face. And I don't know if that makes sense. I mean, for some small language model, yes, it will. There is the process of distillation. So, a small language model will learn from the big language model. But, the ability that we have to influence the pre-training process, it's somehow limited. But everything that happens in context can be heavily influenced by SEO. As we know it, everything can be heavily influenced by creating mentions and in the form of links. The new links, mentions are the new links. So there is a lot of things that you can do.
It's great, and it's tough because it's like everything is dynamic. But obviously, if you have a brand that's been around for 100 years, you have a distinct advantage because you've been able to impact the training. Andrea, thank you so much for this presentation. I know we haven't really had time. We're at time for questions, but if people want to find you, you're on X at CyberAndy, you're on LinkedIn. What is any other ways that you would want people to get in touch if they want to kind of follow up? Yep, Blue Sky.
Totally.
So if you have questions about WordLift, if you want to talk about agentic AI, if you want to talk about Ontology, Ontology, which I love that that's like a thing. Get in touch with Andrea there. And once again, my name is Garrett from iPullRank. If you haven't, SEO Week will be there. We can have conversations. The three, all of us can get in there at SEO Week and just geek out in terms of the future of all this stuff. Thank you, everybody, for joining us. This has been great. And thanks again, Andrea. We'll see you next time.
Bye-bye.